Okay, the same problem as we just solved in 3b, right? Okay, only now we've made it into a 1 turns into 2, right? So let's just draw a picture. We've got this ball, right? And we exert a force of 5 newtons for 3.5 meters, right? Okay, and then we want to know when it reaches a height. Of course, we figured out that it goes 10.5 meters in the previous problem, right? So the question is, when it reaches a height of 6 meters, how fast is it going? Okay, it's not 0 because it hasn't reached 10.5 meters. That's the highest it's going to go. We figured that out in problem 3b, right? So this, and then the fact that this is the third question, right, tells us that this is a 2 to 1 or a 1 to 2. Now I'm going to argue that the only thing we've got is force times distance, right? It starts at rest. It has no potential when it's at the lowest point. So therefore we only have force times distance, right? And then that turns into a ball that is at some height, right? And a ball that's moving. So I think that turns into mgh plus 1/2 mv squared, right? So let's work this out, right? So 5 times 3.5 equals 0.17 times 9.8 times 6 is the height that we're supposed to look at it, right? Plus 1/2 0.17 times v squared, because we're trying to find the v, right? So we leave that there. So let's bust this out. 5 times 3.5, 17.5, and then 0.17 times 9.8 times 6, 9.996, plus, and then 0.5 times 0.17 is 0.085 v squared. So now I'm going to go this to minus this, right? 17.5 minus, that is 7, sorry. Okay, and then that equals 0.085 v squared. Okay, so now I guess I divide both sides by 0.085. And I get that it's 88.28 is v squared. Now I'm going to square root it, right? So square root of 9.3958, or 9.4 meters per second. All right, that's our velocity. All right.